In question number 6, it is given that Z1 is 3 e power 1 upon 4 pi, Z2 is 3 upon 2 e power of 1 upon 6 pi, and omega is 2 e power 1 upon 2 pi iota. We have to state the values of WZ1 and WZ2, giving our answer in the form r to the power e iota theta. Now, what we are supposed to know is that when we multiply two complex numbers, the modulus multiplies directly. So this, when we multiply omega by Z1, so this will multiply 3 times 2. So omega Z1 would be 3 times 2 is 6. And the powers of E, they add up as the angles add up when we are multiplying. Or in simple terms, if you have power e power x into e power y, it becomes e power x plus y. So this will become e to the power of 1 upon 4 pi plus 1 upon 2 pi iota. And we can simplify it down and write it as 6 e to the power. So when you take the LCM or put it in the calculator, this will become 2 plus 1, 3. So 3 upon 4 pi iota. And WZ2 would be, so Z2 is 3 upon 2. So 3 upon 2 into 2 would be 3 in, into e to the power of, this will become 1 upon 6 pi plus 1 upon 2 pi iota. And the final answer would be, so multiplying this by 3, we'll get 3 e to the power 3 plus 1 is 4. So 4 upon 6 pi iota, or we can also simplify it and write it as 3 e to the power of 2 upon 3 pi iota. Now in part B, we have to sketch an diagram with origin O showing the points A, B, C, and D representing the complex numbers Z1, Z2, omega Z1 and omega Z2 respectively. So first let's make the X and the Y axis over here. Now starting with Z1, Z1 has a magnitude of 3 and the direction is positive 1 upon 4 pi. So we'll just, let's say roughly this is 1 upon 4 pi and let's say this length is 3. So this will represent Z1 or point A and this angle would be 1 upon 4 pi. Z2 is 3 upon 2, so the magnitude is 1.5, so it will be half of A and the angle is 1 upon 6 pi. So 1 upon 6 pi, if you think about it in terms of degrees, that is 30 and 1 upon 4 pi is 45. So Z2 would be over here, half the magnitude of A, and this angle would be, so this point would be B and this angle over here would be 1 upon 6 pi. Omega Z1 is 6 and the angle is 3 upon 4 pi. 3 upon 4 pi in terms of degrees, if you want to think. So that would be 135, or it would be exactly going over here in between with the magnitude of 6. So let's say this point would be C. This will be 6. And this angle over here would be 1 upon 4 pi, as this total angle over here is 3 upon 4 pi. And finally, D has a magnitude of 3. So it is in the same direction as A, WZ2. And also it has, the angle is 2 upon 3 pi. So 2 upon 3 pi is 120 degrees. So it would be in this direction. D would be, it will have a magnitude of 3. And this total angle would be 2 upon 3 pi. So we'll just write the magnitude over here. And this angle in terms of degrees would be 1 upon 6 pi, or the total angle would be 2 upon 3 pi. Now it says state the geometric effects of multiplying Z1 and Z2 by omega. Now one effect we can see directly is that when we multiply omega by Z1, we added the angle 1 upon 2 pi, which is basically 90 degrees. So we can say, let's say when we added, when we multiplied omega by Z1, so this was Z1 over here. So this angle over here is basically a right angle. So we can say one of the effects is that it is a, so the point has rotated 90 degrees and it has rotated clockwise as the angle is positive. So the angle would be anti-clockwise. And as for point B, it has also rotated the same. But what we can also add is that when we multiplied A by C, the length became double. So we can say it was also an enlargement. The length became double, so enlargement of scale factor 2. And as for Z2, we can say the same. There was a rotation 90 degrees. It was anti-clockwise. And in this case, for B, the original magnitude was 3 upon 2, and now it's 3, so it became double. So we can say the enlargement was scale factor. So again, the scale factor was 2. So this is a geometric effect of multiplying Z1 and Z2 by omega.